Introduction to Tree Maps in Java. Hello, everyone. We're going to look at a vital part of Java's collections framework, which is the tree maps. Tree maps, unlike hash maps, which do not guarantee any order of its element, and linked hash maps, which maintains elements in the order they were inserted. They keep their entries sorted according to the natural ordering of its keys or by a comparator provided at map creation. So this sorting makes Treemap an excellent choice for various real-world applications where order matters. Here is an example of creating a tree map and adding elements to the tree map. For those of you familiar with hash map, you'll see that they look very similar. So comparing with other maps, so hash maps are not ordered, and linked hash maps are ordered by they're ordered by the insertion, and tree map has its own sort entries by keys. So if you take a look at Java collections framework, Treemap is a member of the sorted map interface. And this is ideal if you need to store a large amount of sorted information and you need to retrieve them quickly. Core concepts of Treemap. So the backbone of Treemap is a red-black tree, which is a self-balancing binary search tree. You don't have to know the exact details of red-black tree and how to implement them, but just know that this red-black tree allows Treemap to maintain a balanced order. So any operations like add, remove, and check exist are efficient, especially in O of log n times. This is particularly beneficial when you're dealing with a large set of sorted data. So understanding these differences is really important when deciding which map implementation to use in your Java applications. So here is an example of creating a tree map, and then how by printing these, we can see that the keys are sorted naturally, and this is how you can use a custom comparator for tree map, and you can see that keys are sorted in reverse order when you call comparator. Using tree map in Java. So using tree map in Java is pretty straightforward, especially if you are familiar with how map works. So you create a tree map just like any other map. Adding entries involve the put method, where keys are sorted immediately. Retrieving and removing entries is done through the get and remove methods. Iteration can be done over key sets, entry sets, or values. Additionally, Treemap offers several navigable methods like first entry, last entry, And they can be really helpful in scenarios where you need to quickly jump to specific entries. For those of you who want to know more about these operations or any additional operations, please feel free to take a look at Java references on Treemap. So here is an example of using entry set to iterate over Treemap. And then here is method calling method first entry and last key to find out what the first entry is, what the last key is. Practical applications of Treemap. So you might be wondering where the Treemap fit in the real world. There are many cases, but just to give you an example, say you are building an application for a conference schedule, then sessions are planned throughout the day. You need to quickly find where a session fits and retrieve the next or previous session, and sometimes even remove a session. If you have this use case, then Treemap would be perfect for this because Treemap maintains these sessions in a time-sorted order, allowing developers or users to efficiently manage the schedule. And Treemap is also frequently used in scenarios involving sorted data that users need to navigate through, like documents or record. And this is an example code managing conference sessions sorted by start time. So we have a Treemap that has local time as key and string as value. Then this will be easy to find a session after a given time. And also you can call higher entry to find the next session. Common pitfalls and issues. So we looked at Treemap. We can see that Treemap is really powerful, but Treemap also comes with its quirks. For example, Treemap cannot have null keys. So if you try to use a null key, Treemap will throw a null pointer exception. And performance-wise, while Treemap provides efficient log n operations, the tree balancing can become costly if you need to update tree frequently. And also when you're using comparators, you want to make sure that comparators are consistent with equals to avoid any unexpected behavior. So being aware of these pitfalls will help you use Treemap effectively. Here is a code example. If you try to put null key, this will throw null pointer exception. And you can try using a custom comparator. And if you put person, and this might not behave as expected. Conclusion, so as we wrap up, try to think about how you might use Treemap in the project. Treemap is a versatile, and so when used correctly, they can significantly enhance the functionality and performance of your application. And if you want to have a good understanding of Treemap In Java, I encourage you to take a look at any additional materials. Thank you, everyone, for your attention.